So, good evening, everyone. Good evening, everyone. Greetings from Italy. Greetings to Russia. I guess most of you are in Russia somewhere. And so we are back to this biomechanics online course with the second part, which is including 4 modules. I remind you that in the first part we have been dealing with basic concept about biomechanics. So we have been discussed the very basic concept of the central resistance, forces, how moments are created, and I mean it was a rather fast but I hope effective cycle of lectures. And in this second part, we will focus much more on the clinical part, so the tools that we use as an orthodontic appliance to move the teeth rather than talking just of basic concepts. Though, of course, these basic concepts are really important and we cannot forget them. So I hope that those who are attending this course have already been attending the previous modules, or maybe even have had the possibility of watching the webinars again to have a better understanding of the whole thing. So in the last of the 4 modules we had, we were talking about the statically determined mechanics, and I started to discuss about cantilevers, but we were not over with that. So in this first module that we are going mainly to go on with the discussion of statically determined mechanics and cantilever with some more complex stuff. Anyway, before I will try very quickly to give the very basic concepts about statically determined mechanics. Just 10 minutes of that I will use to review a few concepts that we have already seen last time. In the next 3 modules that will complete this course, and today probably I'm going to discuss a little bit about friction, which is something that is involved in what we are going to see with statically determined mechanics, why we could use that rather than sliding mechanics and space closure. So I will complete the lecture talking about sliding mechanics and friction. In the next module, we will discuss about skeletal anchorage, and we will have a 2 hours lecture about skeletal anchorage and mechanics related to that. And then in the third module, we will have to discuss about geometries and alignment. And in the last one, we will discuss about alpha beta springs and V-bends and all this stuff. I mean, it will be a lot of material that we have to discuss in this 4 lectures. So I am just starting immediately. Here is rather hot in Italy. I mean, it's not nice weather, but it's humid and hot. So I'm just turning on and off my air conditioning because I would like to be comfortable in these 2 hours. So let's go on. Let's start again to see what we have said in the previous lecture. So we were discussing about statically determined mechanics. Statically determined mechanics is called so because by knowing one of the 2 force systems that are applied in a 2-unit force system. Here we have 2 units, the posterior unit and the anterior unit. I might draw here. So anterior and posterior. We can measure with the force gauge this force. The problem is that we cannot measure the moment. We don't have any tool available to measure the moment that is generated here. But if we measure this force, and we know that we have only a force because there is a single point of contact of ligature here, we can calculate the force system we have on the other side where the wire is engaged. And this is very simple equation. So we know that we can find the equilibrating force system here just by finding what we say the equivalent force system, and then reverse it. So all this story was explained in previous modules. But the very nice thing is that if I measure this force, I know everything that's going on here, and it's very simple to do it. Even if you don't think to all this, you just multiply this force times the distance, and you know that the force has the opposite direction, and you know that it creates a couple like this, and here we have a moment which is just opposite to this couple. I mean, I want to go fast, so I'm not going to elaborate this so much. So this is the statically determined mechanics, because here we have a single point of contact, and I can measure the force of activation of this cantilever, so I can figure out which is the force that is delivered here. If these are 50 grams and these are, let's say, 15 millimeters, I know that here I will have 50 grams and 50 by 15, which makes 750 millimeters, and we have a moment direction like this. So it's very fast. I mean, whatever you have for cantilevers, what you need to know is a force measurement and a distance. And with this, you do most of it. Okay? So we said a lot about cantilevers and how we can start thinking to the design and selection of the cantilever to solve a specific problem or dental movement, if you want. And what is important to remember, that the design of any statically determined mechanics is related to the needed force system. So it's important to me that you start thinking first, which is the force system I need to apply to my active unit, and then you start thinking to the cantilever. So we have been working with this, and we know that for example, in this case, we are having two molars, so two conditions for the molar. In one case, the moment to force ratio is very high. This means that we have very little translation or movement of the CR by extrusion. In